Welcome to the course of differential equation. In this session, we will discuss on Euler-Cauchy equation. The Euler-Cauchy equation is a special kind of differential, second order differential equation. See, whose general form is x square y double dash, whose general form is x square y double dash plus ax y dash plus by is equal to 0, ax y dash plus by is equal to 0, x square y double dash plus ax y dash plus by is equal to 0. See, compared to the previous this one, compared to previous, the second order homogeneous linear differential equation with constant coefficient, we can compare with that one, ay double dash plus by dash plus cy is equal to 0. This is the second order linear homogeneous differential equation with the constant coefficient. See, compared to this, we have here we have this is with y double dash, we have a coefficient function x square is there, and as like that, instead of b here we have ax is there, and instead of c there is the b only is there. So there have some little difference for this differential equation, that is why we call it as that is a special second order differential equation. So this kind of differential equations are called Euler-Cauchy differential equations. This is what is called the Euler-Cauchy differential equation. See, in the previous session, second order linear homogeneous differential equation with constant coefficient, we used the concept of the auxiliary equation. We used the concept of the auxiliary equation. So similarly, here we have an auxiliary equation for this differential equation also. So the auxiliary equation of this Euler-Cauchy equation is, so we have the auxiliary equation of Euler-Cauchy equation is Euler-Cauchy differential equation is m square plus a minus 1, m square plus a minus 1 into m plus b equal to 0 is the auxiliary equation. See, dear students, here see m square is here, a is the coefficient of the y dash and b is there. So if your differential second order differential equation of this form, then we will write the corresponding auxiliary equation as m square plus a minus 1 into m plus b equal to 0. As we discussed before, this is a auxiliary equation is a quadratic equation. That is a quadratic equation in m. As because this is a quadratic equation m, we can find the values of m by using the formula minus b plus or minus root of b square minus 4ac divided by 2a. Okay. Instead of b square here, instead of a, here we have value is equal to 1, instead of b here we have value is equal to a minus 1, instead of c here we have value is equal to b. So that we will replace here. This is the previously in very early preliminary classes from the 8th standard onwards, you are using this formula for ax square plus bx plus c, ax square plus bx plus c equal to 0. So that is why we just wrote this is here. So actually we replace the values of a, b, c by these values. So we will have values of m. As we discussed before, the discriminant b square minus 4ac may have three choices. The b square minus 4ac has three choices. The b square minus 4ac may be greater than 0, or may be equal to 0, or may be less than 0. Okay, fine. So if b square minus 4ac is greater than 0, we can say that there is two real roots, that is m1 and m2, two real distinct roots. if b square minus 4ac equal to 0, there is a single root, that is what is called a double root, that is equal to this one, m1 equal to m2 equal to m. So, in this case here, suppose if this is less than 0, then m1 is equal to some p plus iq and m2 is equal to some p minus iq is here. m1 is equal to some p plus iq and m2 is equal to some p minus iq is there. Okay. So, the root will exist as complex conjugates. So, there is a slight difference for the auxiliary equation here. The auxiliary equation m square plus a minus 1 into m plus b equal to 0. So, definitely the solution will also have a little difference there. So, that we can say that the general solution, if so, our thought it is that if case 1, we consider the case 1, suppose in case 1, if the discriminant b square minus 4ac is greater than 0. So, definitely we can say that m square plus a minus 1 into plus a minus 1 into m plus b equal to 0 has two real and distinct roots, two real and distinct roots, has two real and distinct roots, that has two real and distinct roots, and that root will say that is equal to m1 and m2. Then the general solution will be here, see a is equal to 1 and b is equal to a minus 1, c is equal to b. So, that we will use here. Okay, fine. See, my dear students, we will get two real and distinct roots. So, that two real and distinct roots will exist, therefore, the general solution will be general solution can find by using the formula general solution can be found by using the formula y is equal to c1 x raised to m1 plus c2 x raised to m2. Y is equal to c1 x raised to m1 plus c2 x raised to m2. Y is equal to c1 x raised to m1 plus c2 x raised to m2 is there. This is the formula. So, similarly, we will have the formula for the case 2 and case 3 also, as we discussed linear solutions of the linear differential equation with the constant coefficients. See, now we found from here it is that if your equation of the form x square y double dash plus ax y dash plus vy is equal to 0, such second order differential equations are called Euler Cauchy equation. Then definitely their auxiliary equation is m square plus a minus 1 into m plus b is equal to 0, and while as because that is a quadratic equation, while solving that quadratic equation we have three choices based on the values of a discriminant b square minus 4ac. In this case, b stands for a minus 1, b is actually a minus 1, and c is b, and the value of a is equal to 1. So, if the discriminant is greater than 0, definitely they will have two real and distinct values for m is there, and the general solution will be y is equal to c1 x raised to m1 plus c2 x raised to m2. So, see, write down a problem, solve an Euler Cauchy equation, solve an Euler Cauchy equation, solve an Euler Cauchy equation, solve an Euler Cauchy equation. T square y double dash, sorry, I would like to say x square y double dash plus xy dash minus y is equal to 0 plus xy dash minus y is equal to 0. I would like to put it as equation number 1. See, x square y double dash plus xy dash minus y is equal to 0. See, just look into the equation. While seeing this is equal to x square y double dash, instead of this is equal to axy dash is there, the value of a is equal to 1 plus by, so the value of b is equal to minus 1. Fine, therefore we can write, to find the solution we can write the auxiliary equation. The auxiliary equation is m square plus a minus 1 into m plus b equal to 0. After assuring whether the differential equation is Euler Cauchy or not, then we can write, if it is Euler equation, we can write auxiliary equation like this. Okay, so m square plus a minus 1 into m plus b is equal to 0. So, dear students, m square is there plus a minus 1, a is actually 1 minus 1 into m plus value of b is equal to minus 1 equal to 0. Fine, therefore, we found from here it is that m square plus 1 minus 1 into m plus minus 1 equal to 0. This will be 0. This will be 0. The second term will be 0. Therefore, finally, we will have m square minus 1 equal to 0. Therefore, we have m square minus 1 equal to 0. So, we can write m square equal to 1, that is m is equal to plus or minus 1. That is m is equal to plus or minus 1. That is m1 equal to plus 1 and m2 is equal to minus 1. m1 is equal to plus 1 and m2 is equal to minus 1. So, dear students, we found the values of m1 and m2. We found the values of m1 and m2, so that we can say, therefore, the general solution is, therefore, the general solution is y is equal to c1 x raised to m1 plus c2 x raised to m2, c1 x raised to m1 plus c2 x raised to m2. So, my dear students, y is equal to c1 x raised to m1 plus c2 x raised to m2. Okay, that is y is equal to c1 x raised to m1 is 1 plus c2 x raised to m2, the value of m2 is equal to minus 1. So, this is the general solution. See, my dear students, we found the general solution as we discussed before in previous sessions. This one C1 and C2 are here, they are the arbitrary constants. Since they are the arbitrary constants, if our problem is either initial value problem or boundary value problem, then we can find a particular values for C. So, that particular values for C. So, on that case we will have the particular solution. Now, this is the general solution. Here our problem is neither an initial value problem nor a boundary value problem. Therefore, till here we can do. Okay, fine. Now, I would like to move on to the next question. Write down the example 2. Solve the differential equation x square y double dash, solve x square y double dash minus 2.5 xy dash minus 2.5 xy dash minus 2.5 xy dash minus 2y is equal to 0. minus 2y is equal to 0. See, dear students, here we have a differential equation is here. See, while evaluating this equation, you may just see to the differential equation of the form x square y double dash is here, and there is the value of a is equal to minus 2.5 is here, and there is value for b here, that is equal to b is equal to minus 2 is here. So, fine, dear students, now this is the differential equation x square y double dash minus 2.5 y dash 2.5 x y dash minus 2y equal to 0 is definitely this is Euler Cauchy equation. This is Euler Cauchy sorry, this is Euler Cauchy equation. This is Euler Cauchy differential equation. So, we can write the auxiliary equation as part of the solution. Therefore, the auxiliary equation is we can write the auxiliary equation. The auxiliary equation as that is equal to m square plus a minus 1 into m plus b equal to 0. Okay, fine. So, we have m square, we can write this is equal to m square plus the value of m, that is 2.5, that is minus 2.5. Minus 2.5 minus 1 into m minus 2 is equal to 0. Sorry, this is m square minus, sorry, m square plus, fine. M square plus minus 2.5 minus 3.5. So, this is equal to m square minus 3.5, that is equal to minus 7 by 2, minus 7 by 2 m, minus 7 by 2 m, minus 7 by 2 m, minus 7 by 2 m minus 2, minus 2 equal to 0. So, we have the auxiliary equation like this. Okay. So, we need to find two values. We need to find the two values, that is their product is equal to, we need to find two values k1 and k2. We need to find two values k1 and k2 such that their product k1 into k2 is equal to minus 2, and k1 plus k2 is equal to minus 7 by 2. So, have to find the values k1 and k2. So, which are that k1 and k2, the values their product is equal to minus 2, that is we can write this one for I would like to take this is equal to 4 into 1 by 2. Okay. Now, we can have 4 plus 1 by 2. See, 4 into 1 by 2 equal to 2, 4 plus 1 by 2 equal to 8 by 2 plus 1 by 2 is 9 by 2. So, at least one of them will be negative, and which one will be the negative one? So, here we need this is equal to negative value, therefore, the highest one is equal to negative value. So, this is minus, this is minus. So, dear students, minus 4 into 1 by 2, that is equal to minus 2, minus 4 plus 1 by 2, minus 8 by 2 plus 1 by 2, that is equal to minus 7 by 2. So, fine, we can use these two values to here. Therefore, dear students, we will have this is equal to m minus 4 into m plus 1 by 2, m plus 1 by 2, that is equal to 0, m plus 1 by 2 equal to 0. So, fine. So, this is equal to, therefore, we can say m is equal to 4 and m is equal to minus 1 by 2 are solutions of auxiliary equation. Are solutions of auxiliary equation. Now see, my dear students, we found the solutions of auxiliary equation m is equal to 4 and m is equal to minus 1 by 2. So see, the solutions are real values and distinct. So are and the solutions are, and these solutions are real and distinct, and these solutions are real and distinct, and these solutions are real and distinct. These solutions are real and distinct. So there is a real and distinct solution, therefore we will have the general solution. Therefore the general solution is, general solution of given differential equation is y is equal to c1 x raised to m1 plus c2 x raised to m2. Okay, so we have c1 x raised to m1, that is y is equal to that is y is equal to c1 x raised to m1, that is x raised to 4, c1 x raised to 4 plus m is equal to minus 1 by 2, m2 is equal to minus 1 by 2. We can write this is m1 and this is m2. So this is equal to c1 x raised to 4 plus c2 x raised to minus 1 by 2. Okay, c2 x raised to minus 1 by 2. Also we can write this as y is equal to c1 x raised to 4 plus c2 divided by x raised to 1 by 2. We will take this is to denominator, x raised to 1 by 2. X raised to 1 by 2 is root x. So this is the general solution of given differential equation. Is the general solution of given differential equation. Is the general solution of given Euler Cauchy differential equation. Okay, see, in both cases what we did here, my dear students, what we did here, it is that we just evaluated the auxiliary equation as we did in the previously. So we evaluated that one, we got after evaluating that one, we got the values of m1 and m2. Since m1 and m2 are real and distinct, therefore we have the general solution as c1 x raised to m1 plus c2 x raised to m2. So we got the general solution. See, write down one more question, my dear students. Solve the differential equation, that is the Euler Cauchy differential equation, x square y double dash plus minus 20y is equal to 0. Minus 20y is equal to 0. So okay, fine. Now see, my dear students, this is the solution, that is x square y double dash plus ax y dash plus by is equal to 0. See, here we have the value of a is actually 0, this is equal to 0. Now what about b is equal to minus 20. Okay, for solution we write the auxiliary equation as auxiliary equation is actually the auxiliary equation is y this one m square plus a minus 1 into m plus b equal to 0. Okay, fine. Therefore, m square plus a minus 1, the value of a is equal to 0. Therefore, a minus 1 minus 1 into minus m plus value of b, that is equal to b is equal to minus 20 equal to 0. Okay, fine. Now, we got the value as m square, this one equation as m square minus m minus 20. See, dear students, here we have a quadratic equation. We have to find two values. You have to you can use minus b plus or minus root of b square minus 4ac by 2a. The same formula you can use, no problem, but we have a simple method. Have to find two values, that is I would like to say 4 and 5. 4 into 5 is equal to 20. Okay, and we have to get 4 into 5 is equal to 20. We have to get the minus 20. One should be the negative, and we have to get their sum will be is equal to minus 1. So, for that, dear students, to get sum minus 1, we put this one instead of 5, we put minus 5. Instead of 5, we put minus 5. Okay. So, the value will be minus 20, and 4 plus minus 5, that is equal to minus 1. Okay, fine. I think you understood it is that this is their sum is equal to minus 1, their product is equal to minus 20. See, my dear students, so we can write this as the auxiliary equation as m plus 4 into m minus 5 equal to 0. M plus 4 into m minus 5 is equal to 0. So, that is m plus 4 equal to 0 or m minus 5 equal to 0. Fine. Therefore, m is equal to minus 4 or m is equal to plus 5. Therefore, m is equal to minus 4 and m is equal to 5. So, the roots are real and distinct. Therefore, the roots of auxiliary equations are real and distinct. Therefore, the general solution will be x raised to m1. Therefore, the general solution will be the general solution of given differential equation is given differential equation is general solution of given differential equation is y is equal to c1 x raised to m1 plus c2 x raised to m2 is there. See, my dear student, just we can replace the values of m1 by minus 4 and m2 by 5. So, we have this is equal to y is equal to c1 x raised to minus 4 plus c2 x raised to 5 is there. Okay, this is the general solution of the given differential equation. Okay, fine. So, this is the very first part of the Euler-Cauchy differential equation, and we can have two more types of the differential equations, Euler-Cauchy differential equation based on the roots of the characteristic equation, that is the auxiliary equation. We just discussed now it is that the roots of the auxiliary equation is real and distinct. Now, we have to discuss the roots of the auxiliary equation will be real and equal, and maybe they are the complex conjugates, that we will discuss in the upcoming sessions. Thank you for watching these videos. Continue watching. Thank you very much.